Algebra 1, Lesson 82, Evaluating Functions, Domain and Range. So starting off with evaluating functions, let's talk about what a function is. A function is just a mathematical notation to express something that shows up on a coordinate plane, or a specific shape that graphs onto a coordinate plane. So here, this problem is read as the function of x equals x squared plus 5. All right? And then here, this one, the function of 1 equals 1 squared plus 5, the answer being 6. So what they're doing here is they're taking this function f of x equals x squared plus 5, and then they're using that function as a rule to apply the function of 1. So what you see here is that functions are actually just a form of substitution. It's a notation that tells you what to substitute where. So in this case, when they did the function of 1, what they're saying is they want you to replace every single x with the number 1. And they substitute inside of parentheses. So let's see what this looks like on our problems. So our homework will give us a problem like this. They'll tell you the function of x is equal to x squared plus x minus 10, and they want you to find the function of 5. So just like I said, all we're going to do is we're going to take this function, and instead of writing x, we're going to plug in the number 5. So instead of writing x squared, I'm going to write 5 squared. Instead of writing plus x, I write plus 5, and then minus 10. From here, all I have to do is solve. 5 squared is 25, plus 5 minus 10. 25 plus 5 is 30. 30 minus 10 is 20. So the answer to f of 5 is 20. Right? So that's one way that you'll see this problem. They'll give you a number, and you have to plug it in. Now the other way that you see this problem is like this. Oh, and then functions don't always have to be using the letter f. They could use the letter h, the letter g, pretty much any letter they want. So let's look at this one. This one says the function h of x equals x squared plus 1, and we need to find the function of h of x plus 2. Now this looks a little scary, but like I said, the rules don't change. So instead of writing x in the equation, everywhere I find x, I'm going to instead write x plus 2. So let's rewrite this. Instead of x squared, I'm going to put x plus 2 squared and then plus 1. So to solve this, I have to rewrite x plus 2 squared into 2 parentheses. Don't forget the plus 1 at the end. And then I have to FOIL. So first times the first gives me x squared. Outside times the outside gives me plus 2x. Inside times the inside gives me another plus 2x. And then the last times the last, or 2 times 2, gives me plus 4. And then I have plus 1 at the end. Now I'm just going to add like terms. So 2x plus 2x gives me 4x. And then 4 plus 1 gives me plus 5. And then the x squared stays the same. So the answer here is just going to be x squared plus 4x plus 5. And that's as simple as we can write it. So h of x plus 2 equals x squared plus 4x plus 5. All right, now that we're done with the functions, let's go to domain and range. So the key thing to remember about domain and range is domain cares about the x-axis, and range cares about the y-axis. So what they're going to do is they're going to give you a graph like this, and they will tell you to find the domain and range of this graph of the line, or of this function. So what we see here is that the line extends off into infinity. Okay, so if we look at the x-axis, we have to ask, is there any value that x cannot be? Is there any value that will not work for x? The answer is no. X can be any number because it's not limited. Now we ask the same question of y. Excuse me. And the answer again is no, y is not limited. So in this case, the domain of the function is going to be all real numbers. Or we would write this like this. We would say domain of f is equal to the set of x as it equals all real numbers. So this is another bit of notation that we have to learn. And then we would say the range of f is equal to y being the set of all real numbers. And the reason why it is this is because there's no number that x cannot be, there's no number that y cannot be. Now what if the domain or the function is limited? Well, we'll have something like this, right? And here, if we look at this graph and we look on the x-axis, we have an open dot at -2. So x cannot be -2. So I'm ignoring the up and down. I'm only looking left to right on the x-axis for domain. So if I look left to right, x cannot be any of these. It cannot be -2, but it can be greater than -2, right? And then we see our line stops right here at 3. So x can be 3, but it cannot be greater than 3. So the way that this domain would look would be like this. We would say that the domain of f is equal to the set of x being all real numbers as long as, like I said, -2, x cannot be -2 and it is greater than -2. So as long as -2 is less than x and x is less than and equal to 3. And then we put our closing brace. So that's what expresses this left and right movement here. -2, +3, right? And we write that as an inequality. X cannot be, or x is greater than -2 and less than and equal to 3, and the domain is the set of all real numbers. So a lot of this stuff you're just going to have to memorize, like x being the set of all real numbers, and then this section should be pretty easy. Now let's look at the range, the y. Now if we look at the y values and we trace the y-axis, we see that y can be 4, but y cannot be, oh wait, no, y can be 3. Okay, so let's trace the y. Y can be 3, but y cannot be less than 0, but it can be equal to 0. So for the range of f, y is going to be in the set of all real numbers as long as 0 is less than or equal to y, and y is less than or equal to, what was it? 4. End of set. All right, so that's going to be the answer to that problem. Now, what if they tell us to find the domain of a function, but they don't show us the picture? So that will look a little bit, hold on one second. Okay, so those problems are going to look like this. The book will tell you to find the domain of the function of x as it equals the square root of 5 minus x. And then they'll have another one, they'll say find the domain of g of x as long as the function of 1 over x. Now there's two rules we have to remember. The first rule is radicals, in as far as functions are concerned, radicals cannot be negative, right? So we cannot have any negative value in a radical. And then the other rule is that fractions cannot be divided by 0. So any value of x that would make a fraction divided by 0 is not okay. Any value of x that would make this radical negative is also not okay. So with that in mind, let's think about how we can solve this. For the radical, if we cannot have a negative number in this radical, we have to ask ourselves, what value of x would make this number negative? Well, if we do 5 minus 1, we still have a positive number. If we do 5 minus 2, still positive. 5 minus 3, still positive. But if we did 5 minus 5, we're at 0. That's okay. Now, what if we did 5 minus 6? If x were 6, then the number would be a negative. So what we do on these is we look at the radical and we kind of solve it as an inequality. So what I'm going to do is I'm going to take 5 minus x and I'm going to set it as an inequality equal to 0, and then I'm going to solve this inequality for x. I do that by adding x to both sides. And so then what I see is 5 is greater than and equal to x, and that gives me my domain. All right? So so the domain of f is in x being the set of all real numbers. That's the part we memorize. As long as 5 is greater than and equal to x, or x is less than and equal to 5. Excuse me. That's how we solve the first one. Now the second one, we're going to do the same thing. All we do is we set x in an inequality greater than and equal to 0, and we plug it into the equation. So since there's nothing happening on this denominator, then that's going to be my answer right there. So I'll put the domain of G is x as it equals the set of all real numbers as long as x is greater than and equal to 0. So when it comes to solving the domain of these functions, all you have to do is take the radical or the denominator, set it as an inequality equal to 0, solve that inequality, and that becomes your domain. Excuse me. If you have any questions, let me know on Moodle, and I will see you in class.